Howdy folks. Today we are looking at something a little bit different. We are going to put together a dim bulb tester. So I happen to be throwing this together out of a really cool little microscope lamp that I happen to have here. But you can use any sort of, anything that'll hold a standard incandescent bulb. This won't work with LEDs, things like that, because you need something that has that actually, consumes power and provides resistance in the circuit, but still lets power through, unlike the way LEDs work. Basically, the way this whole thing works is you wind up putting the bulb in series with your load. And so if your load winds up being shorted, i.e. a receiver that is would otherwise blow its fuse or things like that, the bulb being in series will limit the maximum power through to the wattage of the bulb. So in this case, I've got a 60 watt bulb in here. And so therefore the most that'll flow through the circuit when we're done is 60 watts, which will hopefully prevent, various extra components from blowing up, fuses from blowing, receivers from being destroyed, other fun stuff like that. Potentially in the future, we may move into variacs and things like that as well to bring it up even slower. But I think this is a good step, considering the number of receivers I've had recently, which are, popping fuses and doing other kind of scary things. And I've been hearing from other folks that some of the machines that I'm working on pretty regularly also can kill speakers and things like that without blowing their output fuses. So, kind of towards that end, I figured this is a good habit to get into here. So it should be pretty straightforward to get this done. I'm just going to open up the switch right here. Not with it plugged in, but I'm going to open up the switch here. And then I'm going to just rewire it a little bit so that I'll wind up cutting the end off of this guy, and I'll wire this outlet in series with the bulb, so that I've got a switch to turn the outlet on and off, and the outlet is again in series with the bulb. So if it does try to overdraw, it can't. And under normal operations, the bulb should just give a nice little happy glow at however many watts the receiver is pulling. So yeah, that should be the general direction. And yeah, I guess let's get into it. So as you can see here, this goes off to the bulb. We've got one line that goes straight through, continuous, and then this comes from the plug. So what we need to do is unhook the bulb here. We'll leave the intact line alone, and then we'll wind up putting our load in between this wire and this lug. Okay, so for the first draft, I think that'll do. I'll probably wind up printing up a new case so I can get this mess actually inside the case and just have 3 covered wires coming out, as opposed to, kind of what you see here. But that'll be a future revision. This should be good to just see it work. Alrighty. So, as you can see, the bulb is in series with our outlet here. So now, if we plug in and we flip our switch, nothing will happen. See, the bulb's not on. But let's see if we can do something that is generally considered a very bad idea. Let's see. Okay, so again, this is absolutely not something you would do under any normal circumstance, but this is demonstrating what the dim bulb tester actually accomplishes. So make sure that's off. Then we take a little piece of wire here, and we are just going to short straight across the outlet. Need to pull off a little more. Now we're going to set that over there because we don't really want to be particularly close to it. And now, normally, if you would turn on an outlet while it was shorted like that, it would just, blow up, blow your fuses, all kinds of bad things would happen. But instead, in this case, our lamp will come on. So that is exactly what we want to see. So instead of this wire over here blowing up, getting hot, this is your receiver. Instead, the bulb lights up and you are limited to the amount of current that runs through your shorted out system. So if we want to see what it looks like with something that is not shorted, this is the Sansui that we've been playing with the last couple of weeks. And so if we click on now, that is on. Note that the bulb is not on, but if we turn the receiver on, we get a dim glow. I actually want to give you a better view of that. We've got the tester switched on, and then when we turn on the receiver, you see we've got a light glow here, and it kind of came in hard and then settled down to a lower level. That's as it's charging the capacitors and all that good stuff. If this receiver has been on recently, if you do this with one that hasn't been on recently, it's going to have more that it needs to pull in, and you might see the bulb light up fairly bright in the beginning while it's doing that initial charge. But you can see, if you want to see what it looks like as it draws more power. This is actually running a record here. So you see we picked up some brightness, and as we bring the volume up, yeah, we actually tripped our protection circuit there, I think. There we go. Hear the relay click back in. So we can only pull so much power. We can only pull 60 watts total before the bulb limits us.